Hey guys, welcome back to AlgoYogi. We are doing 2 pointers. Next problem on the list is rotate array. Let's go to the problem on LeetCode. So given an array nums and it's an integer array, rotate the array to the right by k steps, where k is the non-negative integers. Otherwise you'll be moving them to the left. Okay, so first example, nums is this array from 1 to 7 integer total, and then you move, k is 3, so you move the values to right by k, but we're gonna make sure that when you're moving something that's already in the end, it comes to the front, and they've shown it so beautifully in each step. Rotate 1, rotate 2, rotate 3. So k is 3. We have to do this, will be our final answer, but you have to go through these steps, right? So just like here, the 7 was brought in the front, and then rest everything was just moved, shifted to the right. Okay, so let's understand this. How are we going to do it? So k being 3, that means we need to move this entire all the values to right by k, but we have to keep the length will be same, right? So what happens to the value that are in the end? So they actually come in the front. They'll come in the front. So bringing those values in the front, what does that mean? In the first rotation, because k is 3, in the first rotation, what we are going to do is we just take the 7 from here. We take the 7 from here, and then we're just bringing it in the front. So 7 comes over here. 7 comes in the beginning. Okay, and maybe it would be better if I had written it nicely outside. Okay, so 1, 2, 3, 4, 5, 6, and 7. Okay, so in first rotation, what happens is 7 comes over here. This is 7, so this is my first rotation. Second rotation would be I bring 6 in front. I bring 6 in the front, and that too, we're saying like we are moving all these values. If you compare these two, so basically this here remained intact, but it just came over here, right? It came over here, exactly. So what are we actually going to do now? So one of the things that I think is what's really happening is, and let's just write the solution here for this problem after making, after shifting all the values by k. So this will be basically this will be 5 will come in the front, so 5, 6, 7, and then 1, 2, 3, 4. Okay, so this is our final array. But if you see the position of 1 here, position of 1 here, and position of 1 over here, given that this is 0, 1, 2, 3, 4, 5, 6 index, it has been moved, this has been moved by 3 places towards right. So this is coming over here. It came to the third index, right? From the 0th index, it came to the third index. So in that case, how about we just go through the entire array, and we move each of the values by k places towards right, but make sure when we are doing that, then if our new index that we are calculating becomes greater than the length, we try to find the mod, and then that comes so that it can become a circular array, right? So that's one thing, and I think that would be the brute force approach, creating using extra memory, keeping things basically in this new array, calculate that using this new index, which will be shifted by the k values. So using the brute force approach, we just, and when the k is basically in this example 3, what we really want to do is shift all the values. So we'll create like a new result array, and then using I, basically 0, 1, 2. So let me write index here, 0, 1, 2, 3, 4, 5, and 6. So to calculate the same index values, I'm just gonna, pointing them so that I'm writing those updated values over here. So this will be the updated array. So now if you see, if I want to calculate this new value for 0th index, and that I will basically get by shifting, trying to basically access the value from the back, but basically length minus k, that will give me the value, basically trying to access at 0th index, and that will come from, basically if you imagine this as like circular array, that value needs to come, the value that will be coming over here, that will be fetched from the back of the array. So by k places, right, by k places. So you go back, you try to come over here, so that's like 1, and then 2, and then 3. So 5 will be moved over here. So you must have seen that in example. So 5 will come over here, and that is because and how do you get basically this 4? How do you get it? So you basically have you have n, so n minus k, and you add I to it. So n minus k plus I. So in this case, it is, what it's giving us is 6 minus 3 plus 1. It's giving us 4, and this is the 4th index, right? So that's one way, but you can see it's like we're using extra memory over here. So in that case, and remember, we have to take the mode here by n again, because at one point you'll be basically going over the indexes, over the length of nums. In that case, you'll have to come back and take this. So it's like 5 will move here, and when I is 2, then it's like, this is basically kind of constant. So it's like 3 plus 1, which will be this, and then yeah, last time it was 4, now it will be 5, so 6 and 7, and then it will be, basically it will come back to the front, and then 1, 2, 3, 4, yeah, and 5 was moved to here. So this is like the brute force approach, and then you can basically assign these values to nums, because they're asking us to do it in place. So let's do in place now. In place. Okay, you know what, I'll have to get rid of this and write the values again. Okay, so let's write 1, 2, 3, 4, 5, 6, and 7, and k is 3. So what really happened is, now since we have to do it in place, what really happened is these 3 values, because our k is 3, that means that many values from the back of the array will come to the front, right? So these values will come to the front, and that's what really happened. So that's going to happen like 5, 6, and 7, and then all these values were basically moved next to them, right? So 1, 2, 3, and 4. So this is what I mean. So these values, they came from here, these values, they came from here, and these values, they came from here. So these 3 values, and because our k size is 3, so you move 3 values from the back. So that's really happened when we are using this extra space. So how can we basically do the same thing, but do it in place, so that we are not using this extra memory? And one of the solution to that is, how about you have this input array and you use this reverse functionality, but in this reverse functionality, we'll have a common reverse function, and what you really want to do is reverse your array first go reverse your array. So what that will do is it will bring all the values, in this opposite order. It will change the order, so everything will basically be reversed. So it's like 7, 6, 5, 4, 3, 2, and 1. So you see, like, now we have reversed it, and if you see all these three values that needed to come in the front, they are here, but they are in opposite order, and so are this other section. Now they're in opposite order. They're reversed. So what do we do? Now we take each of these sections and then reverse them. And after reversing them, what will really happen is we'll get 5, 6, and 7. This is this part reversed, and then this part reversed is 1, 2, 3, and 4. And this is, my guys, our final answer. Really awesome, right? So this is what we need to do, and we are just reversing it. Reverse function we can write using 2 pointers, so that we're not like using the inbuilt reverse function. So let's implement it. It's really easy, no extra memory, and big of n time complexity, because that will be the time that we will use for reversing this entire array of length n. Okay, so first thing first, let's write a reverse function. And what it's really doing is it takes start, and let's call it s, and end, right? And then what it's gonna do is, while my start is less than end, I just wanna say nums s and nums e. So these two will be basically swapped. These values will be swapped. So at the end will be assigned to the start, and start will be assigned to the end. And this is just a way of doing things in one liner, but you guys can do it using the temp ready. Store this pointer value into temp, and then assign this end, and then assign end the temp. So you can do that as well. S increments, E decrements. Okay, simple. By now we all know it, and then we don't have to actually return it. Now what do we do? As we said, we're gonna first reverse the entire array. So that is length nums minus 1. That's what we do. Start is 0. So we have reversed the entire array. Now what do we do is we're gonna reverse the first part, and that first part is basically is gonna be of length k. So reverse from the beginning until k. Okay, but I think k is since in this case k is excluded, when it needs to be excluded, because when we were reversing, and this has to be an index because we are considering it, we're not reassigning things, so we need to decrement it by 1. And that is because when you are sending k inside, that means we are sending it as index, but that's not what we want to send. K is the number of values that needs to be reversed, so that's why I'm decreasing it. So index start at 0, and this is inclusive, and that goes in. Second thing is, something will start at k. This time it will start at k, and it will go until the end. Okay, so this will go until the end. So and it starts at k. Okay, I think now this makes perfect sense, and we don't need to return anything. That's what's been told to us. So let's try to run it on example, and I really hope it works, because things seem very, very clear. Okay, works on example. Let's submit it. Just a little problem, and that is this, because we have sent length nums minus 1 and nums. Okay, so when nums is yes, this is what we really need to do. I think initially I talked about, but this time I forgot. What if k is greater than the length, right? So this is what's happening over here. K is 2, but my nums is 1. So that's not okay. That's not okay. So we will take a mode. We will take mode of k by the length, so that number of shift is not greater than the length. Then it becomes the same array again, and you don't want to. We didn't take that consideration over here. We did take. It would have been worked fine if we were doing this mode thing inside that. I forgot what I said. I think it was length minus k plus I, a mode length. So that would have worked, but not this time. So length nums minus not minus, actually, yeah, this will work. So yeah, submit it again. This can happen, and I think it's better to do it live when you're writing the solution. So okay, let's write the time complexity. That is big of n, and space complexity is big of 1. Okay, this is big of 1, and voila, this is done. Let's go to AlgoYogi, mark this solved, and see you guys in the next problem. Until then, bye bye. क्या कर रहा हूँ मैं?